My name is Felienne Hermans. I'm assistant professor at Delft University of Technology. If you're on Twitter and if you're tweeting this is my handle, it's just my first name. So you can tweet about it and mention me so I can read what you liked and did not like after the talk. So my talk is about spreadsheets. And many people, developers, think, why on the developers conference are we talking about spreadsheets? Spreadsheets are often mislabeled. People think of spreadsheets as being data, whereas spreadsheets are actually programming. Spreadsheets are code. This is the gospel of my life. I go everywhere, all conferences that want to have me, and I tell people spreadsheets are code. Now, you don't have to believe me immediately. I have 3 reasons for you why you should start believing me, why spreadsheets are actually code. First of all, spreadsheets are used for very similar programming domains. Problem domains. Here you see an investment calculator, you put in some properties, and you get an answer. And this is something you could have built in Java, in Objective-C, in Haskell, it doesn't really matter. A domain is finance, is very suited for programming in any language. And of course you can wonder, why would you do this in a spreadsheet? And I have asked people this. During my PhD project, I worked at an investment bank for 2 years where I researched spreadsheets. So I said, people, why did you build that? Why didn't you buy software or hire someone to build it for you? So it turns out, as developers, we're really bad at making software. Often these users, they have tried this. They've gone to their favorite IT supplier, either within their company or outside of it. And they say, hey, can you build me this investment calculator? And then the software company says, sure, no problem. That'll just be 3 million and 6 months. And then if it were true, it wasn't even that bad. But often then, of course, it is 3 years and 20 million, and it has half the features they want. So from the perspective of a smart end user, doing it yourself in a spreadsheet actually makes a lot of sense. It seems very cheap. So why in a spreadsheet? Because it isn't that easy to make software. So I go to great lengths to make my point. To such great lengths, in fact, that I've implemented a Turing machine using spreadsheet formulas only to show people that spreadsheet formulas are actually Turing complete. So they're proven as powerful as any other programming language out there. So what you see here, every row is one iteration of the tape, because using formulas only, you cannot update cells. And the head is visualized with conditional formatting. Actually, I think in addition to being proof that spreadsheets are Turing complete, I also think it's a pretty nice visualization of a Turing machine, because you see the movement, and it's on my website, you can download it, and if you do, you can put in different state machines, and they map to a visualization of how the head moves. So we sometimes zoomed out and just looked at the pictures. It's pretty cool, and it went somewhat viral on the internet. So if you Google Excel Turing machine, you'll find lots of people who wrote about it. It actually brought my blog down for half a day because it was on Hacker News on Reddit. So people thought it was fun, at least.
Which Turing machine did you implement?
Which Turing machine?
Yeah, which state machine?
Oh, I don't remember. Just like the basic one, I think.
Well, it doesn't count unless you implement the universal Turing.
Oh, yes, okay. That is, of course, true. So the third reason that spreadsheets are actually, you should consider them source code, is they suffer from typical source code problems. For instance, we found that only 1 in 3 spreadsheets have a manual. Spreadsheets are used by 12 different people during their lifespan that averages 5 years. So these problems, they sound a lot like the problems that we had in software in the 70s and the 80s, when people started realizing that the little scripts they built within their company, the little COBOL programs or Fortran programs, were still there 10, 20 years later and were undocumented, and maybe people have lost the compiler. So really similar problem space also. So these are 3 reasons that spreadsheets are actually programming. They're used for similar problem domains, they're just as powerful, and the problems that occur with their usage are the same. So spreadsheets are code. I hope you are convinced me, but I'm going to go a bit further than that. They're not just a programming language, they are the next programming language that you should learn. Resistance is futile. Why? Again, I have a few reasons for you. Spreadsheets are live programming. Who knows who made this visual? From what talk it is? Yes, Brad Victor from Inventing on Principle. So he presents this idea of live programming, where on the one hand side you have the code, and on the other side, in the same view, you have an instantiation of that code. And changing something to the code is immediately reflected in the running environment. No compilation is needed. So, well, this is wonderful, Brad Victor, but we had that stuff since VisiCalc. I mean, the spreadsheet is live programming. You update the formula, and immediately you get the results. No compilation is needed there. Secondly, I know how functional programming is suddenly back in fashion. Everyone likes functional programming. Well, if you like functional programming, you've come to the right talk, because spreadsheets are purely functional. A spreadsheet formula, it cannot have side effects. The only thing a formula can do is reference other cells, and based on the values in those cells, it calculates the result. If you only look at formulas, it is impossible to create side effects. You can only manipulate your own little cell if you're a spreadsheet formula. So they're purely functional. And the third reason that you should actually learn about spreadsheets is everyone knows this stuff but us. Everyone knows how to work with a spreadsheet. Like, your next door neighbor is managing his fantasy football team in a spreadsheet. Your accountant is doing your finance probably in a spreadsheet. Everyone knows this. There are lots of statistics. For instance, in the Netherlands, all inhabitants are surveyed for their computer skills, and over 50% of people knows how to manipulate formulas in a spreadsheet. So you could say that this is enabling everyone to program. It's the most popular programming language ever, except amongst programmers. So I'm going to fix that here today in this room. I will teach you a little something about how to do some amazing algorithmics in a spreadsheet. So what we're going to do is we're going to implement selection sort. It's a pretty simple sorting algorithm that works as follows. You pick a value, the first one, and then you look at where is the minimum in the rest of the values. You select the minimum and you select the first value and you swap them. And then you continue to the second value, you again search for the minimum, you swap them, and this is how you sort the entire row. So what I've added here is just the index. So it's just from 1 to 13. Just this is the first one, second one. For convenience, we will need that later. So the first thing we need for our selection sort algorithm is the minimum. And luckily, Excel has a built-in function for that. We just take the minimum of this row. That is very easy. But we're going to do it slightly differently. And at the end of the talk, you'll understand why I use this. So instead of going from E3 to Q3, I can also use this syntax. 3:3, and that means the minimum of the entire row. This is something that not everyone knows. Remember this because you'll need it later. So what we now want to do is, okay, we know the minimum, but at what position is the minimum located? There is the match function in Excel for this. So we say we're going to search for this value in this row. And this means we want to have an exact value and not an approximation. So that is correct. It tells us that the minimum is at position 1. So let's build our algorithm step by step. What we're going to do initially in this line is not immediately sorting. First, we'll just mark the spots with an X where we're going to swap. And for the rest of the values, we put an underscore just so we can build the formula step by step. So this is a position if E2 is equal to D4. So if we're at the position of the index of the minimum, then we would like a cross there. So this is the formula. If this is equal to the minimum, mark it with an X. We would have expected a cross there, but it's not there. Did someone see what I forgot here? Some dollar signs. Very good, sir. What happens if we select this cell? You can see it. If you take a formula and drag it, all references are immediately updated. So this formula now not refers to this minimum, but to the value right before it. And we can fix that with a dollar sign. If we put a dollar sign in front of a reference and then drag it, it is not updated. So now we get a nice little cross there. And I'm not going to trick you again with the dollar, so I will do another dollar here, because later we're going to drag all the formulas down and we want to be fixed on the index row. Okay, so we know where the minimum is. On the other side, where we want to start at the beginning, first index, and then move up, we have the opposite situation. We know where we are, but we don't know what value we have. So we know we're at the first spot, but we need to get that 13. And there's an index function for that in Excel. So we can say, give me the value on this position. So now we have 13. Now what we like to do is also add a cross in this first cell, because we want to swap, either if we're at the position of the minimum, or if we're at the position where we're supposed to swap. So what we do here, if E2 is equal to B4, then we're also going to swap. So we're either swapping if we're at the index of the minimum, or if we're indexed at minimum, or if we're at the index where we are supposed to swap. So this is the easiest part. This is the thing you can come up with what's supposed to go here. What do we do if we're not swapping? What should go at the spots of the underscore? So this is the situation as it is now. If we've done one step of the algorithm, what's in the spots of the underscore?
The same value.
Yes, very good, the same value. We can just copy the value from upstairs, from one row up. So we're getting close. If we're not swapping, we just take the value up. And what I've done here is I've added conditional formatting, like with the Turing machine, to show you what values I'm swapping, just for convenience, so you see what the algorithm is doing. So what do we get here? If E2 is equal to B4, so if we're at the position of the swap value, what goes there? Yes, the other value, the minimum. So if we're at the position of the swap, we take the minimum. And in a similar fashion, if we're at the position of the minimum, we take the swap value. So this is almost our selection sort. We can take that and drag it down. Unfortunately, again, I've made a little mistake, because this doesn't look very sorted. So what is the mistake here? Very good. I am increasing the position where to swap. However, look, this minimum stays the same because my initial choice was the minimum of the entire row. So I need to change something about that. What I'm going to do here, and Excel has a wonderful function for that called offset. It takes a range and moves that range over the spreadsheet. So I can take this range, and every time I increase my index, I move this range 1. So initially, I move it 0. So that's this 1 minus 1. And then in the next step, I move it 1. And in the next step, I move it 2. So the range I'm taking the minimum over goes like that. And if we fix that, ta 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 ta, selection sort. Isn't that nice? Oh, wait, we're not done yet. This is really nice. We want to go a little bit deeper in all the scary things that Excel has to offer for us. So bear with me. I'm going to make it nicer, but also somewhat darker. Pop quiz. Anyone has an idea what this syntax means? So this is a formula, A5 colon Q5, then there's a space, C1 colon C15. What does this mean? No? Well, there are 2 ranges, so I'm selecting them. Let me select it, and then you get some sort of visualization. Yes, intersection. So for some reasons, above me, instead of just having a function called intersect and then 2 ranges, Microsoft decided it would be very nice to give the space some meaning only in this specific situations, because there are many situations where spaces can be ignored, but not here because now it has meaning. How do you know such things? Have you implemented the entire grammar of spreadsheet formulas, Felienne? Yes, I have. we actually have, of course it is implemented because it's inside of Excel and it's also inside of OpenOffice that have a similar syntax, but it's not separately available for researchers to build all sorts of add-in. So we fixed that by releasing a grammar and parser. It's actually on my GitHub that parses. We drove it on about 1 million formulas and we have 99.9% completion. So this is how I know about this funky syntax, because we analyzed lots of formulas and we actually saw that people use this. And it gets even a bit worse than that. We can use this particular syntax because what we can do now is name this range. We give it the name index. We select these cells and say we now want to give them a name. What I can do now is the formula that I had, if this E2, I can replace it with index. And what I get now is the intersection of index and the E column. So this is, 2 minutes ago I referred to it gets a bit more strange. This is it, because now this E here is optional. I can remove it. So what this means, I see the gentleman looking very confused. So what this means is the intersection of this index range and the cell that I'm currently in. Yeah, that's what it means. So this cell is E4. So if I refer to index from here, it means the intersection of this cell, let's say the column of this cell, and this range. We can repeat this trick. If we give all these columns, so we call this swap and index and min and index min, we can turn this into this. Isn't that nice? Now it looks a bit more like programming, right? We can read this. It's self-documenting. If index is equal to the index of the minimum, swap. If index is equal to index of swap, minimum. There's just one thing here that is annoying. This is, of course, that E3. I cannot use my trick on that because it's an intersection of something else. It's the cell above, so I cannot refer to a fixed row. Of course, this has to go. This has to go because I want to have something nice without any cell references. I know if I'm trying to give you some programming in Excel and it still has E3 in it, you'll say, no, that's not real programming. So we have to fix this, but we have to go a lot more deeper into the special hell that is named ranges of Excel, or heaven, or opportunity, however you may call it. So I showed you already how you can give a range of cells a name. I selected a few cells and I named them index. But what you can also do is name a constant. So I can say the name all you need, and instead of referring it to a certain cell, I can also just put something else there, like a string constant. So now I've defined all you need is love. And now I can call that reference. Look, all you need is love. Love is all you need. Isn't that nice? Isn't that nice? It's a pity that the Beatles never got to see this. Well, at least maybe still 2 of them. There are other songs also that we can turn into magic Excel poetry. For instance, there's this wonderful song by Paolo Nutini. It has a line in it, however much I love you, you will always love me more. Well, let's bring that to a spreadsheet. We define a constant, like we just did. Instead of a string constant, we now define an integer. My love, let's say my love is 15. So what I can do now is I can define your love, which is always more than my love. So I can say your love is 1.3 times my love. So I have a formula inside a named range. I've defined something like a function. You could say it's a function. So I can say, okay, your love is 15. My love is 19.5. And whatever you put in here, this will always be more, obviously, because it's defined as a multiple of that. Another song that we can put in Excel by famous Dutch DJ Armin van Buuren called Every Day I Love You More. So this is like loving to the next level. Because first it just was, okay, you love, I love you more, but now it's every day I love you more. This is an unending, never-ending process. So let's map that in a spreadsheet. Again, let's start at 15 at day 1. What we can do now is use a formula to point to the cell above. And you can use the row function, maybe you've seen this. If you use the row function without arguments, you get the row of the cell that you're calling from. We can use that. So we can create a cell reference to the cell above us using, we make a cell address out of our row -1 and our column. So if we put that in now, here, we just have the string value of the cell above, the location of the cell above. And Excel automatically puts in the $signs here. So we're close, but we're not there because we don't want the location of the cell, we want the value of the cell. And what Excel has is an indirect function that you can feed a string and it will evaluate that string. It's very much like the eval function in JavaScript. You put a string in and you get whatever is represented by that string. So if you take the indirect of the string B3 is equal to what is in B3. It's the same thing. So intuitively, you just chop off the quote, but what it means is give me whatever is on this string. We can use that. So we can say we don't want to have the location, we want to have whatever in there. So now we have a formula that refers to the cell above it. The only thing we now still need to do is put in the Van Buren factor, however much it is that I love you more every day. We just add that. So we say today's love is yesterday's love times a certain factor. We can drag this formula down. So all these cells, this is like if you want to trick your coworkers with a crazy spreadsheet, all these cells refer to the same named range, but they all have a different value because they're secretly referring to the cell above with some sort of formula mumbo jumbo. So this is, of course, what we all need to attack this E3. I'm not here to talk about love songs, I'm here to talk about selection sorts. So we can use this crazy magic to get rid of that ugly, nesting, eye-bleeding E3. It needs to go. So what we can do is we can define in a similar way that we were just defining yesterday's love, we can define a function, a named range, called previous row with a very similar formula. It is referring to whatever is above us, the row above us. And here, when I told you in the beginning, you need to pay attention to that syntax of row, column, row. That is what I use here. So here, I don't need to have the column values. I can just say the row -1 and the row -1. So I create the string of the cells above me and refer to it. Look at that. Now it's like real programming. No one ever anymore can say that this is not real programming. If the index is index min, you get swap. If the index is index swap, you get the minimum. And otherwise, you get the previous row. Isn't that nice? It's, just for comparison, I've also implemented selection sort in Python. It's not that concise. It's lots of letters. Actually, I don't know what version I would like better. Well, I know what version I like better, but like, if you wouldn't be as biased as me, I don't know, Python. This seems pretty nice too. So the idea now here, and that's actually what my research is about. My research is not about doing crazy Excel stuff. The idea of my research is, if spreadsheets are code, could we apply methods from software engineering to spreadsheets to help people build better spreadsheets? Like I said in the beginning, the problems that we recognize in the spreadsheet domain, a lack of documentation, a long lifespan, artifacts being transferred from one person to the other without really deep knowledge, these are the type of problems that well, I wouldn't say we've solved them in software engineering, but at least these are the type of problems that we worked on for the last decades to get people to build better source code. And initially, when I started my PhD project, I wasn't hired to work on spreadsheets at all. The assignment of my PhD project was to build a domain-specific language, a DSL for finance. So I started doing a small case study at an insurance company. Me being a computer scientist, I was surprised. Everyone in that insurance company was building spreadsheets. They were all programming, but not in a proper way. So I went back to the university and I said to my supervisor, look, they don't need a DSL in finance. They have a DSL in finance. It's called Spreadsheets, and it's not very good. So let's try with all our knowledge from the software engineering domain, let's make it better. What those guys need is an IDE. That's what they need. They can just build software like we build software. Like I wrote BASIC when I was 10, just like writing and trying. But what they need is support, professional support like professional programmers have. And that actually resulted in my PhD dissertation called Analyzing and Visualizing Spreadsheets. And you don't have to read the whole thing because the conclusion is, yes, we can. We can very easily transform methods from software engineering to spreadsheets with very little effort. It's very easy to talk about the same concepts in spreadsheets. So one of the examples that we did is we built a refactoring tool for spreadsheets. So initially we started with a smell detection tool that could tell you this formula is very long or these things seem very connected, and people like that. And they wanted to improve upon their spreadsheets. So we built a refactoring tool. And it can detect formulas like this one you see here. It's not very elegant. It's the sum of something divided by the count of something. You could also use an average there. And it could be due to the fact that this person didn't know about the average function. Maybe not so probable for an average. But in other scenarios, sometimes people use very complicated sums because they don't know about the sum if. For example, this is a refactoring we support too. So you can ask our tools, give me applicable rewrites. Give me things I can do with my formula. And then it says, yes, we found something for you. The sum and count to average refactoring. And we even give them a preview, like many IDEs also have. This is how your formula will look like. And this is a slightly older version. In a newer version, we also check if, given the values that are currently in your spreadsheet, the refactoring won't change anything because there are sometimes subtle differences even between the plus and the sum in Excel. It's not always the same. So at least we check if the change doesn't mess up your spreadsheet as it currently is. And you can apply then this transformation within a cell, but you can also apply it within a range. And these transformations are entirely programmable. So we did make a number of default refactorings, but if you don't like them or if you want to have others, you can define your own transformation in a language that's very much like spreadsheet formulas. And we imagine that power users that can use very complicated formulas or write VBA could also write these transformations and then apply them on their spreadsheet. And then it gets a bit broader than just refactoring. Then you could also do transformation of business rules. So suppose you're changing how you evaluate mortgages, you could write a transformation rule for your formulas and then apply it throughout an entire spreadsheet. It's sort of a powerful find and replace. And then of course, you should know this one. I'm okay if you didn't know all the spreadsheet answers, but someone should get this right. If you say refactoring, you say test. Very good, of course. We cannot give those poor spreadsheet people a powerful refactoring tool if they don't have tests. How will they know if everything is okay? Of course, we can check against the current values, but you want to have something more safe. And initially, this was some sort of ivory tower thinking. We were like, how are we going to get spreadsheet users to test? It's already so hard to get normal developers to test. How are we going to convince spreadsheet people to add tests? This will never work. And then we actually looked at some spreadsheets and we looked at what people did, and it turns out spreadsheet users are pretty good testers. We found lots of formulas like this, test formulas, you could say. So something like, if the sum of these guys is not 100, I'm just going to output the string error. And otherwise, I'm outputting the string 100%. These type of formulas are common. We found them in about 10% of formulas have this form. They look at a certain value, and if it's not whatever they expect, they output a certain string. So we saw many cool different versions. We even saw things like, okay and good and bad, but also smiley faces and saddy faces as outcomes of these tests. So people apparently do use this, but because just there is no N unit or J unit for Excel, what they use is what they know, formulas. So we thought, why not exploit this? Why not use this observation that people already do it and use that to generate the first version of a test suite? So we've built another plugin called Expector, and what it can do is it can find these existing tests in your spreadsheet. So for this, you get a pop-up and we say, hey, we found this cell in D10. It appears to express that this sum should be 100%. And we have a list of heuristic words, so we know that error is okay, and okay is okay, and saddy face is probably failing. So we can guess whatever it is you're doing. And if you like it, you just tick the marks and you can save the tests. Now they're saved in a hidden worksheet that we call a test suite. They just think there's some magic that knows what is happening in my spreadsheet. And you can run all tests. So you can click this button, you get a pop-up, and it says, yay, all your tests pass. This is a test. This sum should be 100%. And you see that we have slightly transformed this original formula into something a little bit more readable behind the curtain. What you can then, of course, also do if you have a test suite is visualize test coverage. So users can click, show me what is tested. We don't use coverage. And then it says, hey, these cells are tested. So we color all the test cells. And to make it a bit easier, we have a very simple definition, of course, of coverage. We just say, OK, this cell is tested, and it uses all those cells. So let's consider them tested too. Everything that leads to this cell is tested, because at least if something goes wrong, it will all trickle down together in this cell. Of course, we're not talking statement coverage and branch coverage here. If this is a very complex conditional, we're not at all looking at are all the different branches of the conditional covered. We just say, okay, this area of the spreadsheet seems to be fine. What we then do, once we've got people hooked to the idea of testing, is give them a little bit more in very small doses. So not make them responsible for testing everything. We will give you a few suggestions. So you can pick, I want to test a complex formula, I want to test a formula with a big value, or I want to test a formula with many precedents. So a formula that has lots of cells that it depends on. So if you click it, we select a very complex formula. This is, again, where we use our smell detection algorithm to determine how complex the formula is, because we know a little bit about it. And then we say, OK, this looks sort of complicated. If C4 is yes, well, I don't even know what it says. It looks complicated. If you say yes, make tests, we give you a few options. So you can do a few built-in tests, like it should be a number, this is the threshold, the upper bound, the lower bound. And in a slightly newer version, we also have an option here to define your own formula, because this turned out to be a little bit too simple. So now we also have formulas. You can just express whatever you want there. It should be odd, it should be even, it should always start with an A, whatever you want. So you save that. And you get, wonderful, you've increased your coverage from 6% to 8%. So we try to make it a little bit fun. And then these thresholds are added to your test suite. So if you run tests now, they're added too. So the idea here is really, and actually this is the idea of my entire research, is look at what people are doing and make something useful for whatever they're doing. Small increases. Of course, you could say, and I always get this question, so I can just answer it right now. People say, why are you fixing this obviously broken system? Why aren't you working on something better than spreadsheet, something to replace spreadsheet, a fourth GL or a fifth GL? This is not working. I think it's very interesting to observe the success of spreadsheets and make it a little bit better, make it a little bit safer, because for reasons that are not perfectly clear to me, somehow spreadsheets hit the sweet spot between being expressive enough to run entire banks and the things I've seen with spreadsheets, entire risk management dashboards, managing an entire department. It's expressive enough to do that, but it's simple enough to make everyone feel like they can do something. You just put the data in a spreadsheet, you play with it, and then suddenly you have a dashboard. It's very a low threshold. Apparently, it's a very inviting environment. So why not keep that power and make it slightly better instead of throwing all the power out of the window and building something entirely different? So both these tools are available from my website, felienne.com/bumblebee and felienne.com/expector. Actually, we're running a user test with Expector right now. So if you have people that you know that like spreadsheets, or maybe tomorrow at your job, or the day after tomorrow, you decide to stop Haskell and you're going to build all your enterprise systems in spreadsheets, then please join this study, download the tool, and we monitor in the back, we monitor what type of formulas you test and how frequently you use it, because we really want to understand how it works in a real context. So before we go to questions, I think we have some time. I will summarize my entire talk in 30 seconds. So if you missed anything, you're sleeping or doing your email or you came in late, that is fine. This is your second chance. And for those who were here from the start, this is, of course, optimal preparation for question asking. Spreadsheets are code. This is the most important thing. Tell all your friends, if you're on Twitter, the rest is not that important, just spreadsheets are code. Why are spreadsheets code? Firstly, they're used for a very similar problem domain. Secondly, they're Turing complete, so they're just as powerful. And thirdly, they suffer from typical software engineering problems. They're even cooler than just a programming language. They have all the hip characteristics that are in fashion. They are live programming. They're purely functional. Yet, contrary to maybe Haskell, everyone can use them very easily. So I demonstrated how powerful and fun spreadsheets can be by implementing selection sort in a spreadsheet. And this is the entire idea for my research. Spreadsheets are code, so we can make them better with tools from software engineering. We build a refactoring tool and a test tool to make spreadsheet users as professional as real developers. So if you want to know more, this is my professional website, my personal website, and the Spreadsheet Lab is the website of my research group, where I force a few grad students to also enjoy this. If you want to connect, well, I'm here today, I will be at the drinks, I'm here tomorrow as well, but you can also send me a tweet or send me an email if you don't want to hang out with me in person. Or you could ask a question now. So the question is, how do you define a complex formula? Well, read my dissertation. It has lots of details. We have a number of metrics for that. So a few things we take into account is the number of different functions. So if it's just one sum, it's easier than a sum and a plus and a divide. We also look at the number of ranges a cell refers to. If it's just one or two, it's easier than if you get cells from everywhere. We also look at the locations of the cells, because it's a lot harder to refer to a cell from a different worksheet. You have to go there and go back. So a number of metrics. Yes?
You mentioned about 10% of the formulas you were looking at were for error checking, or well, pseudo error checking. Did you speculate as to why 10% of these formulas existed in the first place? Like, why are people actually writing these themselves in the first place without any problems?
So the question is, why would people add test formulas? Yeah, why do you add test formulas to normal code?
You know, you stated, for example, that typically it's hard to get programmers to even write any test cases. So why would...
If I may, but
Yeah, go ahead.
isn't it common in accounting to always test, like you do one thing and the other one, and so I would expect people using a spreadsheet to have the discipline from accounting or whatever.
So is it, I would speculate that perhaps it's the domain that these people who are using spreadsheets are working in. They have, for example, either regulations or checks that they have to implement to make their lives easier, whereas programmers might not.
Yeah, this is very true. So the very financial spreadsheets will look at, for instance, my income and outgoing money. Is it equal to each other? And also the example that I showed is also a common example where it's really about input. So you give this form to someone and he has to make sure that the percentages match. And I guess by experience, people send a spreadsheet to someone, they have to fill it out, it comes back, and then they see, oh, wait, it doesn't add up. So I think they want to move that process closer to whoever's entering data. But this is speculation. I guess it also has to do with people's experiences of spreadsheets having errors. They know that there can be a mistake in either the data or in the calculation. So checking it for yourself just makes it easier. That's also, of course, a big difference between spreadsheets and normal programming is spreadsheet is one package with data and formulas, whereas a program is independent of whatever data you run through it. So some of the tests are also very much aimed at checking the quality of the data. Do I have enough? Aren't there any values below 0 or something like that? Yeah.
How did you get hold of all the spreadsheets that you studied? Because I thought people would be quite scared of giving you financially sensitive.
Yeah, so how did I get all the spreadsheets? These tests, we did that on a very small data set that other researchers gathered that, we used that a small set that researchers gathered just by Googling, but the very big set we have, this is another talk, it's also on YouTube, where spreadsheets are typically attachments to email. And there was this wonderful company that made my research a lot easier called Enron. They went bankrupt, and as part of the investigation, their email servers were made public. So we crawled all those emails, and now we have, and we also open sourced that corpus of spreadsheets. So we have all these spreadsheets. This is a very nice research paper if you want to read it, where we looked at the spreadsheets and we also crawled the emails. So we did some text analysis and we saw very interesting emails. People like, hey Harry, I checked your spreadsheet. There seems to be an error in it somewhere. So you also see that the culture about, people talk about updates to spreadsheet. Can you give me that new version? So thank you, Enron, for going bankrupt and being investigated, because now we have this wonderful data set. And one of the things we're also analyzing, though we probably cannot really publish about, is all the leaked Sony files. Lots of spreadsheets there that we have them. Maybe I shouldn't say that. We could potentially, if we would have them, analyze them and not publish about it, because we don't really have them, I swear. Anything else? Yes, sure.
What I really like from your talk is the fact that you have a really good lesson on UX for developers, because as you say, why don't you rewrite this? And for you, you saw that they are already using this makes sense for them, let's improve that. And I think usually we are always trying to rewrite things or not seeing the value or whatever is there. Like
yes.
Improve the interface or I don't know what that is.
Yeah, this is very true. So that liveness, so those ideas that Brad Victor presents are not actually his. They are way older. They're, I think, from papers in the 70s and the 80s that described as a design feature for UIs. You should have this liveness. It's a lot easier if you can directly look at your values. And I hope that due to Brad's popularity, somehow this liveness will go into normal mainstream programming language, because obviously it's very, very powerful to have your data right there and to be able to manipulate it and get direct feedback.
Are you only identifying naming-related errors, or do you have, for example, productivity tools like Sharp or C# will let you know if you have a statement that always returns true and stuff like that? Do you do that as well?
Yeah, the question if we only analyze name-related errors, we also do similar things. So we have specific smells, for example, for the VLOOKUP. Look at my blog. We have a whole paper about very detailed intricacies in how a VLOOKUP works, and we warn people if they use it the wrong way. If you use it over a non-sorted range, it won't work in certain situations. So we have that type of, it's more static error checking than smell detection, but we have that too.
Okay, we need to interrupt here because there is the next talk. So Felienne will be
I will, yes.